So if we want to use this as a impetus and for a nuclear renaissance in the United States, and drive this pump with nuclear power, not because we'd have to, because the Clearwater system originally was designed to generate 23 gigawatts, but if we wanted to, so that we'd have more freedom to maybe use some of the water down south for agriculture, then we could. However, I also want to emphasize the importance of thinking about colonizing these new areas of the United States. And to do that, we have to bring people. And that requires cities. And around the nuclear power plants and thinking about new cities, we want to pull together on the design table of this project also what the new country would look like in 50 years from now, were we to build this and build cities around the project as a whole. You've seen from the top to this part, and Stuart, if you could again play from 6 minutes to just at a half speed. I'd like to then invite Terry Bates to present his thoughts on city building in NAWAPA. But first, let's just fly through this. So again, here we are, the flow out of Flathead Lake. That tunnel right there is the Clearwater Tunnel, which takes you from Montana into Idaho. The first reservoir at 2,800 feet is pumped up at Loxaw 250 feet into Loxaw Reservoir. The water goes through a tunnel into Selway Reservoir, formed by damming the Selway River. The first Selway Lift #1 pump is a 350-foot lift. Immediately thereafter, you have Selway Lift 2. That's a 550-foot pump lift. You'd have there you'd have a nuclear plant there. We have a very long tunnel then, which goes from Selway Reservoir into Salmon River Reservoir. And you can see there the Selway Reservoir goes around. We have a dam that creates Salmon River Reservoir. Salmon River Lift pump #1 is 700-foot lift, 700 feet. That's like pumping water from Lake Mead, or over the Hoover Dam back into Lake Mead. That's the big guy. That would require 7.7 gigawatts of power itself. Then we have Salmon River Lift 2. It's a 350-foot lift. That requires about 3.8 gigawatts. And then Salmon River Lift #3, the last one, 250-foot lift. And then it goes from there, this is now through the Sawtooth Mountains here, 50 miles down into the very end of the tip of Idaho there, and cross into the state of Utah. So that's a 50-mile long tunnel and 80-foot in diameter. So you can pause it there. Yeah, 80-foot in diameter, which again breaks the boundaries of I think the widest tunnel is 60-foot in diameter, which is also just more like mud and not rock. And that's, I think, around Niagara Falls or something, the widest tunnel that was done. So if you could have the lights and invite Terry Bates.
Some time ago, Michael asked me to talk about the cities required to do the things that have been discussed here this afternoon. And I find it really easy to get off subject, so bear with me. Also, I don't have any pride of authorship, so if any of you have comments, suggestions, or want to argue, that's fine with me. We'll just get in a fur ball and fly right at it. Let me just tell you a little bit about myself first. I attended University of Nevada mining engineering and Humboldt State University in forest engineering. I got a couple different degrees, and I'm very pro-engineering type guy, contrary to what Keith had said. My philosophy is you're better off to make mistakes on paper than you are in steel. And so also my philosophy on engineering that I've participated in is I like to turn out projects and documents about 95 to 96% complete, because you can't afford to be 100%. Only NASA and Boeing can do that. And I found that the fabricators and the machinists will find 3 or 4% of the errors, and the construction guys in the field will find the other couple percent, and then it's a 100% job. And they say, why in the world did you put this stairway through the MCC? I said, well, why don't you just move it over a little bit? Okay, you know, that sort of thing. And so this way everybody wins. But on these waterways, particularly through Idaho, it's going to require a lot of people to do this. And people have to have a place to live. And Michael asked me some various questions. For those of you who didn't happen to hear that interview, what are you going to do about cities and places to live? And so my approach would be, well, first and foremost, strategy versus tactics. If your strategy is wrong, it doesn't matter how well you tactically implement something, it's going to fail. Halsey wanted to go to Midway, and Roosevelt wanted to go to Alaska because he thought the Japanese were going to attack at Alaska, and Halsey said, I think they're going to attack at Midway. So the huge difference in strategy. And it wouldn't matter how fast we got what was left of our fleet to Alaska, got there very quickly and efficiently. We weren't attacked in Alaska other than just a tiny little bit. We were attacked in Midway, and so Halsey elected to go to Midway, and it was a perfect strategy, even though the tactical implementation left a little bit to be desired. And this is critically true in this project, I believe. And then, just getting off the subject a little bit, but I promised to get back to it, Michael was saying something about Speaker of the House feels this and that, and how do you feel about something? I couldn't care less how you feel about it. What I want to know is what you think. But thinking's hard, and most people don't do it. You'll hear news people say, well, how do you feel about this? I don't care how you feel about it. You know, what do you think about it? Because a lot of times you may not like the answer that you come up with when you thought about something. Wow, I wish I didn't think that would happen, but it does. I feel like I don't like that, but I think that's what it's going to be. So, and then also, Michael talked about the crisis of the nation, and we hear about consumers all the time. Consumer this, consumer that. I couldn't care less about the consumer. That's right. What I'm interested in is the producer, people who run machines and produce something. These are high-paying jobs, and before you can be a high-quality consumer, you got to be a high-capacity producer. Whether you're in construction craft or whether you're in fabrication and machining or whatever it is that you're doing, produce first, and then you can consume stuff. But this emphasis on the consumer, I believe, is totally misplaced. So let's produce some cities, for example. And the question was, if we have a revival of city building all across this arid region, and some of it isn't very arid, but it's just unpopulated, how would you approach it? And so my approach to it is if it's a greenfield city or town, then I suggest that we build these facilities or plan these facilities on something other than agricultural land. You know, I mean, look what happened to Pasadena, California. Used to grow the best oranges in the world, and now it's paved. You know? So if we have a choice, let's build our communities and our cities on something other than prime agricultural land. And then I also suggest, and this might be news to you, because I just changed it, that we'd actually have perhaps a plan of a footprint of 3 different sizes. Let's say villages, towns, and cities. And a village might be, for purposes of argument, something less than 15,000. And we may have villages associated with pumping stations. These pumping stations are going to have to work a 4-shift operation 24/7. and that requires management. It requires machinists. It requires operators. It requires security. These are all people that are going to be occupied with pumping stations, and whether we do it in a single lift of 600 feet, which I think is unlikely, but we'll leave that up to the engineers, it'll probably require 2 or 3 pumping stations. As you know, static head of water's what, 0.4335? Anybody know? Anyway, it's a little less than half a pound. Yeah, it's a little less than half a pound, 0.4335. And then when you include friction and head loss and temperature differences, you know, pump inefficiencies, I don't know that your tunnel is going to withstand 400 psig. Isn't going to do it. So you're going to need multiple stations, and maybe even not tunnels in some areas, maybe penstocks, pipes, things of that nature. But that's off in the future a little ways. So in any case, a village would support perhaps a pump station. Then we have a town, and a town might be anywhere from 15 to 35,000 people, and that might support a nuclear plant, because they require a lot of people to operate too. And whether we have to refuel them every 25 years or every 5 years or 18 months, it doesn't make much difference, because we still got to pull the generators and the turbines down every 3 years. We have to look at the bearings, we got to look at the windings, we got to meg the darn things, see that they're not going to arc across, and so on and so forth. That begs the question of standby power. And people have already mentioned natural gas, and I suspect that we're going to find ourselves bringing natural gas down in parallel with this waterway, so we could have gas-fired boilers as well whenever our nuke is down for whatever reason, so we can maintain the load.
Most of the time, like N reactor, they were able to valve out those turbines and repair the turbines while the reactor stayed running.
Great.
Perfect. Do that same
you could do that same thing too, and the one that they just showed here that was modular, that is really exciting.
Right.
But what I know about nuclear power, you could put in a thimble and see the bottom nicely.
Yeah, and several hundred megawatts, you can fabricate them here at Hanford and bring them up on trucks,
yeah,
or rail cars.
And you got the skill set here. The people, I mean,
right.
They're here.
Yes.
Don't let them get away.
That's right.
You're talking 3.5 megawatts. Okay.
Mm-hmm.
Most of these things are putting out like, maybe 800 to 1,000. So you need 3 of them just to run some of those pumping stations.
Yeah.
And then you got redundancy with 3 of them.
If you go redundantly, you can run plants in and out.
That's right.
Right.
So that you can maintain a certain amount of power and have a little reserve.
Right.
And have some spinning reserve.
Sure.
Right. Well, we'll get to the spinning reserve here in a little bit, because there's things that we can do with that too. And you'll find that I tend to repeat myself over and over here, but anyhow, a city might be something greater than 35,000, and I doubt if you're going to get a large city in this particular area. I don't think you're going to find a 100,000 city. It's just that we don't have that. It ain't going to happen, you know. But what you will find is you'll have populated areas associated with large reservoirs and lakes for recreation and any number of reasons. And even in areas that have some inclement weather in the winter, will still can be a viable city. Look at Sandpoint, look at Coeur d'Alene, you know, nice places, but they're associated with big bodies of water, and this project has big bodies of water. So it'll be a desirable place to live along these waterways.
And these cooling towers that were built here in the 5 plants, they were the first thing built and the last thing needed. They weren't needed. The intention was to use that heat for process heat in factories around the plants. This was scuttled.
Cogeneration.
The true term of cogeneration. That's exactly right. Yeah. So you're going to have lots of excess heat available, particularly with certain types of reactors, and that heat could be used for cogeneration. Could be used for chemical processes, or who knows, make glass. I don't know.
Better than throwing it in the air, that's for sure.
That's right. I suggest, and this is subject to any kind of arguments, that the cities are the communities, villages, towns, cities, be somewhere between 75 and 100 miles apart. For a couple different reasons. During construction, these are commutable distances. and our population base isn't going to support anything any denser than that anyhow. You know, in the old days, in this part of the world, your towns were the distance apart that you could ride a horse in a day. That tended to be about 25 miles. But now we can drive a car, so let's get them spread out just a touch more. Does that make sense? Then the towns, cities, and villages would, I think from an engineering point of view, and I hope we don't take all the money in the cost of engineering, but usually if it's a greenfield, architects and engineers, whether it's a mechanical design or city, or anywhere from 5 to 7% of the total cost, they would share similar or common layouts. I think it just makes sense. And urban planners can decide what that might be, but this would minimize engineering and construction costs. Once we build one place, then we go build another one, and we just did that once before, and so we just got through building a hospital, and pretty soon we get real good at it, or we laid down ductile iron pipe for a fire system, and the pipe fitters got it down pat after the first one, and away we go, because we're repeating ourselves over and over again, so it's easier to do the second time.
Can I say that that would be different than the way the whoops plants were built, in that they were all different turbine generator combinations, different control rooms. Every one of them was a prototype. That's why they were so expensive.
I was on a conference call with Michael a while back, and I was railing against the NRC about how obstructionist they were on building these plants.
That's nasty rules committee.
You betcha. Yeah. And somebody who is a nuclear engineer said, yeah, but the reason why, or one of the reasons why, is they're all different. It's just exactly what you said. And so they had to have the permit process was different for every one of the things. So, you know, if it looks like this has come to pass, we go to Hitachi or General Electric or Westinghouse or whoever builds these things and say, look, we want quotes from you guys to build 12 plants, and they're all going to be the same.
Yes, exactly.
And so once we get a construction crew that's going to burn more than 3 rods a day on a job,
I would argue with that.
then we just start repeating ourselves. The permit process hopefully gets a little better, and away we go. But you're right; it has to be commonality of devices.
Stamp them out like cookies.
That's right. And I also said that in laying out a community area, give it a little bit of thought. In the larger towns and cities, you know, put your industrial areas downwind for a couple different reasons. For smoke or dust or noise or any number of things, you know, give a little bit of thought. Let's not build a smelter upwind of a town. That's not a good idea. Primary and secondary schools should be in the suburban areas and not in towns. Obviously, colleges or hospital offices, city centers, and so forth would be in the city center. And now from a little bit of a utopian point of view, in larger cities, I would attempt to minimize vehicular traffic in the city centers and to encourage small ATVs or golf carts or electric scooters or bicycles or things of that nature, so that you commute to the perimeter and you get on a monorail train and go to work. And so only your emergency vehicles or delivery vehicles or people passing through visiting would actually drive to the city center, and we just try and keep that down a little bit. Plus we got lots of power from our nuclear plants, so we could plug in these cars and scooters and things. That's right. And even if you put a quarter in a meter, that I don't know what it's going to be, but even if it's 8 or 10 cents a kilowatt, you know, put in 50 cents, charge your car.
Actually, you can do it like Disneyland with their monorail that goes in a circuitous route.
Exactly so.
You don't make one line that you have to go this
Oh,
way
no,
and
no,
then
no.
come back the same
That's
way.
exactly.
You go round and round and put as many trains on there as you need.
And that's a good example, is the way they've done it in Disneyland. That is a slick system. It really is.
Should have done that in Seattle.
Yeah, that's another topic.
Get that
City
model.
Council didn't want to do that 40 years ago because they had too much money invested in the budget.
Yeah.
Right you are. But speaking of buses, I said we would maximize natural gas or hydrogen or electric-powered vehicles for city, county, trucks, buses, so on and so forth, and have them not quite so dependent on gasoline or diesel. If there's no reason in the world why a bus, if it's going back to his same yard every night, can't fill up on natural gas or hydrogen, because we can use spinning reserve in the power plants.
Not only that, but your waste heat is at high temperature, you crack water,
There you go.
and there's your hydrogen.
That's right.
Stuff like that. That's right. And if we're cracking water, we also get oxygen, and we can sell that for medical gases or welding gases or anything we want. So, and then Michael said, well, what kind of teams would you put together to run a project, such a large-scale project as these? And I said, well, somebody say something?
No.
Oh. I said the city building could be project unitized, especially engineering, so we can keep Keith happy. And once again, common or similar buildings, schools, hospitals, fire stations, police stations, professional office spaces, so on and so forth, would be relatively common amongst all of them. So you design it one time, or maybe 1.5 times, and you might just change color or something like that. Or if somebody wants to put in their own money, if you get a attorney moves in and he wants to design his office his way or have it done, fine. Otherwise, this is what it's going to be. Once again, common or similar infrastructure, modular perhaps, on water systems. Fire, sanitary sewers, storm sewers, things like that would be common components. Maybe different scales because of population densities, but similar components. Electrical distribution systems, the same way. So your unit substations are similar, cheaper. And once you put them in one time, they're easy to do the second time. I suggested that specialized construction teams for the above items could be very efficient. And then we already talked about this utopian vision of mine of elevated monorail system into the city centers from the suburban areas. And I don't know, maybe that's too expensive. Maybe an embedded rail system is better or cheaper.
Electric trolleys are cheap.
Pardon me?
Electric trolleys are cheap to put in.
Yeah.
And you're gonna have all this electricity anyway.
Once again, I was, like I say, we tended to repeat ourselves a little bit. We already talked about the commonality of stuff, but any new filling station should be designed to accommodate hydrogen and natural gas as well as gasoline and diesel. I thought that nuclear power is the key component probably. Again, a common design or designs seems reasonable, and we just discussed that. And it expedites engineering, purchasing, erection cost, permitting processes, and things of that nature. We could utilize the newly constructed canals and rivers and lakes for cooling. Makes sense. Raise the temperature a few degrees. The fish like it a little bit better, so it's not freezing quite so much.
You could actually farm much bigger fish if we wanted
That's
to.
right.
You could.
Yeah, bacterial growth and all
Yeah,
things.
yeah. I mean, you don't want warm water, but you don't want water that's, 38 degrees either. So if it's getting up around 41, 45, that's super for fish.
They also have the high temperature gas cooled reactors where it's just recirculated and they don't even use water.
Stuff like that, see? It's nice when somebody knows what they're talking about. Well, we already talked about one large facility could accommodate or could be associated with several pumping stations. And there was a time when I was toying with the idea of modular and small reactors similar to what the Navy uses on submarines or aircraft carriers. And they're very good at it. Whatever it is that they do, they're really good at it. And these could potentially be used in some of the pumping stations. So I thought, what if we ran some of these pumps with a turbine rather than an electric motor? I envision these pumps as being pretty large, mighty large, and they may require, who knows, 5,000, 7,000 horsepower per pump, and there's going to be a bunch of them to get the water moving wherever it's going to be moving. And that means that you're going to have a reducer if you go with a steam turbine. And that reducer is going to be the size of this room. And that's expensive, really expensive. Because I was arguing with Michael, I thought, well, so is the motors, and the switchgear is just as expensive as the motor is to start it. Yep. You know, so why don't we, you know, direct drive it. And that way we can modulate the turbine, we can slow it down a little bit if we want to reduce the flow a little, like in the wintertime for some reason or another, or for any other reason. And I waffle back and forth on that. What we really have to do is put a pencil to it. Mm-hmm. But nowadays with VFDs, VFD drives, and being able to switch with solid state devices that can switch high energy and high voltage, that we could probably improve the pulse width modulated variable frequency drives and be able to control the speed of a 5,000 horsepower electric motor. And that motor may be running on 4160 or 13.8 or, you know, who knows. But that would be beneficial. That requires lines from wherever these reactors are and their turbines to the pump stations. But that's not that expensive. You see them all around here all the time, and they're putting in more of them, and there's probably people around that are real good at that. You know? So, like I say, I waffle back and forth, and you just have to do some serious engineering cost analysis on it. Here I said, and the question that we're still on is, how do you see the integrated mass transit system, water systems and nuclear power playing a role in a NAWAPA city? So what I said was, well, perhaps in periods where we have excess spinning reserve in our nuclear plant, that we could use that energy to generate hydrogen and oxygen, amongst other things, for the cars, and sell the oxygen to somebody. So we have oxygen filling, our hydrogen filling stations, and we could have hydrogen powered cars. This is even cleaner than natural gas powered cars. So if you got the power to do it, you might as well. And then he talked about, he asked me what are the challenges for this, and somebody had already touched on it a little bit, and I have his number one challenge is international agreements. People are a little touchy about their borders and things of that nature, and I think it's a challenge. But I know from my travels back and forth to British Columbia, you know, Vancouver and Victoria and whatnot, Williams Lake and so forth, that in periods of a weak moment, they sort of regard themselves as 51st state, actually, but they're real proud of themselves in the meantime. But nevertheless, to take the water from the McKinsey and it leaves, that's going to require some pretty delicate negotiations, I think. And the people in British Columbia don't think a whole lot of the folks over there in Quebec. Yeah. So it's a lot like the people in Washington don't think a whole lot of the people in Washington, D.C. It's the same thing. I think we have eminent domain issues, and there's going to be problems of condemnation, and it'll be enough work for 1,000 attorneys.
Is that all?
Well, look at the pipeline in Alaska. That's a pretty good example. That was a huge engineering project, and they had to cross what, 60 rivers and in 60 below zero up to 80 above zero, and this pipe has to survive that. I mean, it's a terrific engineering challenge in addition to a construction and fabrication challenge. That pipeline, does anybody know how long it took to build it? From start to finish. 2 years.
I know it wasn't.
Almost to the day before the first drop of oil flowed. But the whole project was about 10 years long because of the litigation.
Done about 9.
That's right. That's right. Yeah. So don't underestimate the legal issues of this. That's my point.
That pipe's a special alloy to take the temperature and change it to.
Oh, it's amazing. It's just amazing.
9 grown.
Yeah. And we've already discussed the system paying for itself through water and power sales. In addition, I would expect you could lease recreation land for people that are going to go up and bring their trailers up to the lakes, and those property would probably be owned by NAWAPA, and you could hire operators for these lands, and they could tell people to bring your trailer in for 20 bucks a night or 15 bucks a night, or make some money doing that. Other issues are budget and monetary issues, and from my experience in projects, somebody had asked about capital project estimates. You want to try and be pretty close, and it's a lot of money. This has got zeros behind it, and so it's going to have to be divided into bite-sized chunks that you can understand. And when you start talking about $500 billion, I have no idea what that is. But if we start talking about a single pump station, now maybe we can say, oh, I know what that's going to cost. That rascal's going to cost $75 million or whatever it is. And now we need 8 of them. So if we divide this, and this city is going to cost this much, and engineering costs are going to be that, and property acquisition, and so on and so forth. That way, if you make a mistake in your estimates, it doesn't actually impact the overall project cost very much if you got it divided up into bite-sized segments that you can comprehend.
Well, when you're using credit, long-term credit, that isn't significant. Also, the Federal Reserve just recently came out and told how much they actually have created. They've created $16 trillion. A good portion of it went to European banks.
Wow.
So if they can create 16 trillion, we can certainly create 16 trillion in credit that will be returned.
Wow.
You were talking about
I can't even
orders of
comprehend that.
magnitude.
Yeah.
We worry about pico. We really worry about pico.
Yeah.
10 to the minus 12.
Yeah.
And yet we spend trillions of dollars to get 10 to the minus 12th exposure to prevent exposure
Right.
at that level.
Michael just brought up something here a little while ago, security. For these plants, they would be a terrific target for people that wanted to do us harm. Gee, let's go blow up a pumping station. Holy smokes.
Especially the environmentalists.
Yeah.
Eco-terrorists.
Yeah. Geez. On a smaller scale, I'll tell you a security story. We would have equipment on one project delivered, and we'd rented a very large warehouse. It used to be a plywood manufacturing area, and we'd rented that warehouse to put in stuff that had to be put in out of the weather that we weren't going to use. Electrical stuff, motors, sensitive bearings, things like that. And this was a construction craft job, so the Teamsters claimed the warehouse. That's fine. So they managed warehouses. And the company at that time, my title at that time was called the Manager of Manufacturing and Engineering Services for International Paper Company. And the company had sent an auditor to a mill up north here in Washington. And this auditor went into the paper mill and presents his credentials to the watchman, to the guard. So the guy lets him through, gives him a hard hat and a little name tag. And he's a company guy. You can come on the property, right? So he's running around, and he ends up going into the electrical shop for some reason or another. And he's talking to some of the electricians. And they have warehouses or shelves of components and parts and stuff that necessary to keep the mill going. So he's asking all the questions, how do you account for this, and so on and so forth. Well, then the electrician got a whistle. He says, hey, I got a whistle, I got to go. They need me. So he left. He leaves the auditor alone in this warehouse. So the auditor opens his briefcase and grabs a couple, size 4 starters or something, and puts them in his briefcase and leaves. Then he leaves the plant site. Then he writes a scathing letter of how he could steal this stuff, and nobody checked anything. He goes, here's what I took. And so I got the word from my boss that he was coming down to my job. So I went to the Teamsters. I forget, the guy's name is Howard or something. And I said, Howard, if a guy shows up here, that he's an auditor from the New York office, you let him in, and then when he leaves, you search him. And if he's stealing something, he goes, I told him, I said, you call the police and you take him down hard. And he says, can I hurt him, boss? I says, no marks. Other than that, you can have your way with him. So anyway, that's sort of a rambling dissertation on some of the things that I've been concerned with, and I'm sure that you could each double it easily. And
you have to finish telling the story. You did catch him, right?
No, he didn't come. I think he got word that I had my trap set.
Okay.
Yeah, because one of the other guys was going to fix him up in town with a young lady that had a communicable disease. And, so that didn't happen either.
Well, I just say first of all, on the question of reserve power.
Yeah.
One of the big things back in the 70s and 80s was a design for nuplexes, which were power parks, where you'd have 50.
Oh, I got that. Yeah.
50 gigawatts of thermal efficiency, because power plants are normally 40% or so efficiency. So you have to have a few thermal to get one electrical. But the idea was that you have to therefore have ahead of time which industries are going to link up to that system, because it's not just electrical power that then someone's going to be able to just come on link up to anytime they want. But if you're going to use thermal heat, high 2,000 degree temperatures, to split methane and then combine the nitrogen with the hydrogen afterwards, or the carbon afterwards, and get different kinds of chemicals that you'd want at a much cheaper, in the sense of physical power requirements, physical labor requirements of society as a whole to cause this action. With nuclear, it's almost free as comparative with electrical, and that's being unused, completely unused, and it was junked. And there were some ideas of the seawater electrical reactors, but as far as actual use of this thermal heat and setting up many 50 gigawatts of power, 15 thermal, 10 electrical, and then having a whole industrial park of these things. That's just one. Something
That's
to add
exciting.
to
Yeah.
And it's you get a sense of the. We want to build this project. Now we want to say, let's build these new cities with these kinds of power parks. Just one of them would require reviving U.S. manufacturing and all the chemical industries involved to an extreme degree, but it would also and it would require us going away from the so-called private free trade market model, because this is forethought in planning out all this whole complex. So I don't know if you had anything more on that.
No, it's just I don't know enough about that to make an intelligent comment, but other than it sounds like a super idea. And then to reiterate, with the amount of construction people necessary for jobs of this magnitude, I think we would have a pretty robust apprentice program for people of some sort, yeah. And then now we got a generation coming up that has some real skills again.
Go.
That's why I thought this idea of, bringing kids in for a manufacturing week, and giving them the flavor, give them a taste of that, because so many of them don't have any idea. But that, the kind of, for one thing, kind of wages those jobs generate. But, you usually get a young person's interest. And then, you know, and then the feeling of accomplishment you get when you actually
Do you have a combination of organized labor, like National Chamber, along with your other groups that you've identified to sit down and form that coalition to
That's a
have
good
the
point.
iron torch and ready to strike?
Well,
I mean, you
that's
gotta put all the players in the pot. They've got to see past the political downside of what's happened to this nation in the last 6 years, shutting it down, and realize that the only way we're going to jumpstart this economy and really get it going to create real jobs. Does something like this with a residual. Everybody's looking for that formula in D.C., but nobody's gone to it and opened it up.
No,
I'll say this. The way that LaRouche laid this out strategically is, he said you essentially have three components. You have obviously the general population. Then of course you have the political component, and then you have what this represents, the the builders committee, the construction, engineering, and so forth, right? And he laid it out that we had to get what's happening here first. You had to have the policy or the project, worked out to as good a degree as you can. You can't obviously work out all of it. You don't even know what the hell we're going to run up against, but to have it ready to go, and only then can you actually start, hitting the other aspects, the political.
Right. Because the population runs to their political representative and they say, hey, where's your expertise? You say, right here. Vice versa with the politicians. Say, well, is this project feasible? Why, yes, it is. And what about this? Well, we thought that through. And what benefit will this have? Yes, that's been taken care of. Okay, I'll go with that. I'll tell my constituents, because then they're going to ask me who to go to, and I can point them to what. So on the other question, though, it's come up again on the accounting side of it. You do have to find out how much everything's going to pay, but not because you have to scramble then for every part of it, because we're not going to get some rich guys together who are going to finance any kind of project like this. Infrastructure is government, and that's why our government right now is lost its mind, because that's what it's supposed to be responsible for is not being taken care of. Secondly, this project is impossible without, again, the dumping of this international speculative system. We may have been able to do something 2000, even 2007, but when we had the complete blow-up of the entire system in 2007, Lynn and LaRouche, who then organized an immediate firewall against the speculative wave, said that we would have no possibility at that point of dealing with anything within that old system, and it had to be then completely junked, which is why Glass-Steagall and the other measures. That has to change. So once that changes, however, and then we have the clear program, we'll have no problem in financing NAWAPA as a government program, this time with even more clarity than the Roosevelt period, because we've been so clear that the national banking system that would allow you to issue the credit through the Congress and then the Treasury, and then make the project liquid over a long period of time. It's just an after effect of government management of this kind of program, completely feasible. And I put a video on our website called The Thanksgiving Message, which reviews the credit system and Hamilton's system. So you do have to figure out how these things are going to cost, but not because you're going to scramble up money for it, but because it's a method of accounting. That's what money is. Money is a means of exchange through which credit of nations are transferred. It wasn't that because of the Venetian and then the Dutch system and then the British system, which from 1620 to 1688 basically set up that system in Europe. And England was conquered by William of Orange in 1688, and by 1694 England had been completely colonized by the Netherlands, which was an outpost of Venice. And Bank of England was set up in 1694 as modeled in the Bank of Amsterdam. And these banks were not for the nation. They were speculative. They took over. They reduced the living standard of England by 50%. And it's exactly that system then which became an empire in 1763. That's when the British Empire began. And it's that system that then Hamilton's banking system in 1781 and 1789-90 began to form an alternative to money. Money as just this usurious system, but now money as a means of exchange, and you use banks not for usury, but you use banks for just organizing and coordinating your system. And so when we're talking about this project and how you're going to pay for it, you're just doing it because you want to account. You want to account for it, not because you got to manage your economy as a lot of these Republicans that just got elected are saying, like a household. You don't manage the economy like a checkbook. You don't balance your budget. You don't pay for what you need to do this year by the revenue of this year. That's not how nation states function. So with that, I'd like to, we're going to conclude our formal event here today. Just a moment, Hal. I want to introduce Hal Cooper.